Hi students, welcome back to the channel. Today I am going to discuss about the continuity and differentiability. In that, first part is that continuity. What is a continuity? To explain the continuity, I am taking an example here. F of x is equal to 1 if x is less than or equal to 0. F of x is equal to 2 if x is greater than 0. Look at the graph of this one. When I am approaching the 0 from the left side, when I'm giving the value from the left side, negative, from the negative to the 0, the output is giving is an 1. At x equal to 0 also 1 it is giving. When I am approaching the 0 from the positive to the 0, then output is giving is an 2. From this, what we can give the conclusion is that left hand limit is not equal to right hand limit, because left hand limit is 1, right hand limit is 2. Therefore, left hand limit is not equal to right hand limit. From this, we can give the conclusion is this function is not continuous at x is equal to 0. From this example, I can define the continuity. What is the continuous function? A function f of x is said to be continuous at x equal to c if and only if limit should be exist. Limit should be exist means left hand limit must be equal to the right hand limit, and that must be equal to the value of the function at x equal to c. Then these three are equal. We can say that the function f of x is continuous at x equal to c. Okay, let me take as one example to explain this one. Discuss the continuity of the function f given by f of x is equal to modulus of x at x is equal to 0. Okay, now I took as a definition of a modulus function. F of x is minus x if x is less than 0. That become positive x if if x is greater than or equal to 0. Okay, now clearly the function is defined at x equal to 0. Here what is the f of 0? 0, because at x is equal to 0, what is an output? X is there. In the place of x, I am going to substitute the 0. F of 0 is equal to 0. Then look at the left hand limit. What is the left hand limit at x equal to 0? Limit extends to 0, f of x is equal to left hand limit nothing but less than 0. What is an output? Minus x. Minus x means I am going to apply the 0 means that equal to minus 0. The minus 0 is nothing but a 0 only. There is no difference between the minus 0 and plus 0. Okay. Same way I will apply the right hand limit. What is the right hand limit? Limit extends to 0, f of x. The greater than 0 means what is an output? Plus x. That is I am going to apply the limit that plus 0 nothing but a 0 only. And what is the conclusion we can give? F of 0 also 0, left hand limit also 0, right hand limit also 0. Therefore this function is continuous at x is equal to 0. It means that the left hand limit, right hand limit, value of the function 3 also coincide at x is equal to 0. And we can look at the graph of this function, modulus function. When I am giving the negative value, then also it is a positive value. Then when we approach it from the negative, it will also approach us to the 0 only. Then if we approach it from the right side, from the positive to the 0, then also it is an approach us to 0. If we draw the graph, it will be continuous. There is no discontinuous in this graph. Therefore this function is continuous at x is equal to 0. Then okay, we are discussed about the particular point. Now let me discuss about the all the values in the domain. A real function f is said to be continuous if it is a continuous at every point in its domain. Then only we can say that function f is continuous. It means that suppose f is function defined on a closed interval a comma b, then for f to be continuous, it needs to be continuous at every point of closed interval a comma b, including the endpoint a and b also. Then we can say that function f is continuous in its domain, otherwise continuous function. Okay, for this I'm going to discuss the one example, that is then find all the points of discontinuity of the greatest integer function defined by f of x is equal to greatest integer function, where this denotes the greatest integer less than or equal to x. In this we have to understand what is the greatest integer function. Okay, now what is the greatest integer function? If I will take as an input as a 2.3, what is the meaning of this one? I want to find as an greatest integer which is less than or equal to 2.3. If I write as an output 2.3, it is not as an integer, therefore which is the integer less than this one? So many are there, 2, 1, 0, but in that greatest is 2. This is the greatest integer. Same way 2.9, 2.9 is a not a greatest integer. I want to find less than of this one, again it will be the 2. Like that, this is the output of the greatest integer function. Let me discuss about this one, where is they are the discontinuous, where they are the continuous. Look at the graph of this one. What is the graph? Now I will take as an 2 points here. When the when the value become non-integer, when the value become integer, what is happening, whether it is a continuous or discontinuous. Now first I will take as a non-integer. For example, I will take it as a value 3.6. One value I will take 3.6, it is a non-integer. 3.6, what is the value of the greatest integer function for 3.6? 3. I will take his left hand limit of this one, that is an 3.5. What is the greatest integer function for 3.5? 3. Then I will take as a right hand limit 3.7. What is the greatest integer function for 3.7? That is also 3. It means that value at the value of the function at the 3.6 is a 3. Then left hand limit also 3, right hand limit also 3, then 3 also equal. Therefore what is the conclusion we can give? That the function greatest integer function is continuous at all the non-integral. Okay, now look at the integral. What is happening now? I'm taking as an function one value to explain for this one. I will take as a 2 as an integer. What is the greatest integer function for 2? 2 itself. I will take a left hand limit. What is the left hand limit? Nearest value of the 2, that is a 1.99. What is the greatest integer function for 1.99? That is a 1. What is the greatest integer function for 2.0001? That is in 2. It means that from this we can give that left hand limit is not equal to right hand limit when the input is integer. It means that greatest integer function is not continuous at x is equal at all the integral values. It is a continuous at all non-integral values. Let me take general explanation. Let c be a real number which is not equal to the any integer. It is evident from the graph that For all the real number close to c, the value of the function is equal to c. Therefore, limit value is equal to the c and function value also equal to the c, greatest integer function c. Therefore, hence the function is continuous at all the number not equal to integer. Same way, case 2, if c is an integer, then we can find the sufficiently small real number. I will take a small real number which is greater than 0 to explain the left hand limit and right hand limit, such as a c minus r. For example, I took as a 2, small value is a 0.1 less than of that one. If we subtract with that one c minus r, we are giving as an value is a c minus 1 is an output, as like as 1 it gave na, like that. Whereas I'm adding the right hand limit c plus r, what is the giving the output? C only. Here 2.0001, that what is giving? 2 only, that is a c only output is giving. Therefore, left hand limit is c minus 1, right hand limit is a c. From this, what is the conclusion we can give? Left hand limit is not equal to right hand limit at all the integral values. Therefore, which are the point of discontinuous? At all the integral, this greatest integer function is discontinuous. Okay. Since limit cannot be equal to each other for any c, the function is discontinuous at every integral. Okay. Thank you so much. Bye. Take care.